Hello everyone, my name is Hoda and I'm going to talk about economic models of equality of opportunity and their connections to fairness for machine learning. Automated decision-making systems are everywhere and their decisions can be unfair. This realization has motivated an active area of research into quantifying and guaranteeing fairness for machine learning. To make predictive models fair, the first step is to formally define what it means for a model to be fair. Fairness is a controversial concept, so as you might expect, many different mathematical formulations of it have already been proposed. Existing notions of group fairness, which is the focus of this work, require a certain metric quantifying benefit or harm to be equal across socially salient groups. For instance, equality of odds considers a classifier fair if it distributes various types of error, i.e. false positive and false negative rates, equally across different groups. When it comes to these formulations of fairness, unfortunately, we cannot have it all. FairML has already established the existence of trade-offs among various notions of fairness. Importantly, it has been shown that satisfying multiple fairness criteria at the same time is impossible. Now the question is, how should we deal with these findings? Instead of requiring multiple fairness criteria to partially hold at the same time, we focus on selecting the right notion of fairness given the societal context in which the model is to be deployed. To put it differently, we address the normative question of when should we use each notion of fairness? We do this by mapping the recently proposed notions of algorithmic fairness to economic models of equality of opportunity. This offers a unifying framework for viewing the existing notions of fairness, and importantly, it allows us to explicitly spell out the moral assumptions underlying each one of them. In addition, this approach confers a moral meaning to the impossibility results that I just told you about. Okay, with that upshot in mind, let's get started. Quick note that I will be focusing throughout on supervised learning and I will use the standard notation, although I don't really expect you to closely follow the notation and math. I'm just leaving them on for the computer scientists in the audience. Let me begin with a little bit of background about equality of opportunity, or EOP. EOP is a widely supported ideal of fairness in political philosophy. Unlike equality of outcomes, EOP makes a distinction between morally acceptable and unacceptable inequality. The idea at the heart of equality of opportunity is to emphasize the importance of factors for which people can be held accountable and minimize the impact of circumstances and arbitrary factors. These are factors for which people cannot be held responsible. Economists have proposed several models for EOP. At a high level, these models assume that an individual's outcome is affected by two main factors, his or her circumstance C and his or her effort E. Circumstance, or type C, is meant to capture all factors for which the individual should not be held morally accountable. For instance, in the context of employment decisions, we may consider gender as circumstance. Effort E captures all accountability factors, those that can morally justify inequality. In our example, we may consider years of education as effort. I should emphasize that economic literature refers to E as effort for the sake of concreteness and brevity, but E is meant to summarize all accountability factors, those that are viewed as legitimate sources of inequality. For any circumstance C and any effort level E, a policy phi induces a distribution of utility or well-being among people of circumstance C and effort E. In our example, we may consider wage to reflect the utility. An EOP policy will ensure that an individual's utility will be, to the extent possible, only a function of their effort and not their circumstances. Next, I will tell you about two variants of EOP, one called Rawlsian EOP and the other one Luck-Egalitarian EOP. As we will shortly see, the difference between these two is in how they treat E. Rawlsian EOP assumes E is interpersonally comparable, and in particular, it assumes that the level of E is not affected by circumstance C or implemented policy phi. It then requires that for individuals with similar effort level E, the distribution of utility is the same regardless of circumstance. Going back to our employment example, suppose we have four applicants, Alice and Bob. Let's say they both have 5 years of education, and Anna and Ben, who have 3 and 7 years of education respectively. Rawlsy and EOP would require Alice and Bob to have the same wage prospects because they have similar years of education. Unlike Rawlsian EOP, Luck egalitarian EOP offers a relative view of effort and allows for the possibility of the circumstance C and implemented policy phi impacting the distribution of effort. In this setting, Romer, an economist who has extensively worked on formalizing Luck egalitarian EOP, argues that in comparing efforts of individuals with different circumstances, we should somehow adjust for the fact that those efforts are drawn from distributions that are fundamentally different. As a solution, he goes on to propose measuring a person's effort level by his rank in the effort distribution of his type rather than by the absolute level of effort he expends. Luck egalitarian EOP requires that people sitting at the same quantile or rank of the effort distribution for their corresponding type all have the same distribution of utility regardless of circumstances. In our employment example, Luck egalitarian EOP suggests that we should look at everyone's rank in terms of years of education among applicants of their own gender. Among females, for example, Alice is ranked first and Anna is ranked second. Also among males, Bob is ranked second and Ben is ranked first. A Luck egalitarian EOP policy would ensure that Alice and Ben have the same wage prospects and may indeed assign Bob to a less desirable position than Alice, even though they have similar years of education. The key idea here is that being a female has likely played a negative role in Alice's chance of getting more years of education, so the EOP policy should make up for this. Now let's draw a formal connection between the recently proposed notions of group fairness for supervised learning and economic models of EOP. Observe that in practice, predictive models inevitably make mistakes. Sometimes these mistakes are beneficial to the subject and sometimes they cause harm. We posit that in this context, EOP would require individuals who are similar in terms of what they can be held accountable for to have the same prospect of receiving this advantage or disadvantage, and this should be irrespective of their irrelevant characteristics. We distinguish between an individual's actual and effort-based utility subsequent to being subjected to algorithmic decision-making. We define an individual's advantage or total utility U as the difference between their actual and effort-based utility. Our main conceptual contribution is to map the supervised learning setting to economic models of EOP by treating predictive models as policies, irrelevant features as circumstance, and effort-based utilities as effort. Our work offers a moral framework for determining the appropriate notion of fairness in a specific context. With the application domain in mind, we need to decide what factors should be considered accountability. How can they be summarized into scalar? And what is a suitable notion of utility for decision subjects? Once we answer these questions, we can define the appropriate notion of fairness with an EOP rationale tailored to the societal context in question. We argue that answering such questions is outside the expertise of computer scientists alone and ideally has to be resolved through the appropriate process with input from stakeholders, domain experts, and social scientists. With our framework, we can explicitly spell out the moral assumptions underlying existing notions of fairness for binary classifications by viewing them as special cases of EOP. For instance, equality of odds can be thought of as an instance of Rawlsian EOP, which implicitly assumes that the true label appropriately summarizes what a decision subject can be held accountable for. Similarly, predictive value parity is an instance of Luck egalitarian EOP, and it assumes that the predicted label or risk reflects an individual's effort-based utility. Our framework also allows us to interpret recent fairness impossibility results in a new light. As I just mentioned, different notions of fairness make very different assumptions about which subset of decision subjects deserve the same outcome. And depending on the context, usually only one, if any, of these assumptions is morally acceptable. We argue, therefore, that unless we are in highly special cases, it is often unnecessary from a moral standpoint to ask for multiple fairness notions to be satisfied simultaneously. For further details and the discussion of several real-world scenarios, please have a look at our paper. Thank you.